Extensible Messaging and Presence Protocol is a communications protocol for message-oriented middleware based on XML. The protocol was originally named Jabber, and was developed by the Jabber open-source community in 1999 for near real-time, instant messaging, presence information, and contact list maintenance. Designed to be extensible, the protocol has also been used for publish-subscribe systems, signaling for VoIP, video, file transfer, gaming, Internet of Things applications such as the smart grid, and social networking services. Unlike most instant messaging protocols, Xmpp is defined in an open standard and uses an open systems approach of development and application, by which anyone may implement an Xmpp service and interoperate with other organizations' implementations. Because Xmpp is an open protocol, implementations can be developed using any software license. Although many server, client, and library implementations are distributed as free and open-source software, numerous freeware and commercial software implementations also exist. The Internet Engineering Task Force formed an Xmpp working group in 2002 to formalize the core protocols as an IETF instant messaging and presence technology. The Xmpp working group produced 4 specifications, which were approved as proposed standards in 2004. In 2011, RFC 3920 and RFC 3921 were superseded by RFC 6120 and RFC 6121 respectively, with RFC 6122 specifying the Xmpp address format. In addition to these core protocols standardized at the IETF, the Xmpp Standards Foundation is active in developing open Xmpp extensions. Xmpp-based software is deployed widely across the Internet, and by 2003, was used by over 10 million people worldwide, according to the Xmpp Standards Foundation. History: Jeremy Miller began working on the Jabber technology in 1998 and released the first version of the Jabbird server on January 4, 1999. The early Jabber community focused on open-source software, mainly the Jabbird server, but its major outcome proved to be the development of the Xmpp protocol. The early Jabber protocol, as developed in 1999 and 2000, formed the basis for Xmpp as published in RFC 3920 and RFC 3921. Note that RFC 3920 and RFC 3921 have been superseded by RFC 6120 and RFC 6121, published in 2011. The first IM service based on Xmpp was Jabber.org, which has operated continuously since 1999 and has offered free accounts to users of Xmpp. From 1999 until February 2006, the service used Jabbird as its server software, at which time it migrated to Edgebird. In January 2010, the service migrated to the proprietary M-Link server software produced by ISO Limited. In August 2005, Google introduced Google Talk, a combination VoIP and IM system that uses Xmpp for instant messaging and as a base for a voice and file transfer signaling protocol called Jingle. Google has since added video functionality to Google Talk, also using the Jingle protocol for signaling. In May 2013, Google announced Jabber compatibility would be dropped from Google Talk for server-to-server federation, although it would retain client-to-server support. In January 2008, AOL introduced experimental Xmpp support for its AOL Instant Messenger service, allowing AIM users to communicate using the standardized, open-source Xmpp. However, in March 2008, this service was discontinued. As of May 2011, AOL offers limited Xmpp support. In September 2008, Cisco Systems acquired Jabber, Incorporated, the creators of the commercial product Jabber XCP. In February 2010, the social networking site Facebook opened up its chat feature to third-party applications via Xmpp. The Facebook developers site notes that Facebook Chat does not actually run an Xmpp server internally, but merely presents an Xmpp interface to clients. Consequently, some server-side features like roster editing cannot be done via Xmpp. Similarly, in December 2011, Microsoft released an XMPP interface to its Microsoft Messenger service. Skype also provides limited XMPP support. However, these are not native XMPP implementations. Strengths: decentralization. The architecture of the XMPP network is similar to email. Anyone can run their own XMPP server and there is no central master server. Open standards. The Internet Engineering Task Force has formalized XMPP as an approved instant messaging and presence technology under the name of Xmpp. No royalties are required to implement support of these specifications and their development is not tied to a single vendor. History: Xmpp technologies have been in use since 1999. Multiple implementations of the Xmpp standards exist for clients, servers, components, and code libraries. Security: Xmpp servers can be isolated from the public Xmpp network, and strong security has been built into the core Xmpp specifications. Flexibility: custom functionality can be built on top of Xmpp. To maintain interoperability, common extensions are managed by the Xmpp Standards Foundation. Xmpp applications beyond IM include group chat, network management, content syndication, collaboration tools, file sharing, gaming, remote systems control and monitoring, geolocation, middleware and cloud computing, VoIP and identity services. Weaknesses: does not support quality of service. Xmpp does not have the ability to set the timing flow of messages, preventing Xmpp from becoming practical for many embedded distributed real-time, machine-to-machine, or IoT applications. High overhead for embedded applications. As a text-based protocol, Xmpp has a relatively high computing and network overhead. In-band binary data transfer is inefficient. Binary data must be first base 64 encoded before it can be transmitted in band. Therefore any significant amount of binary data is best transmitted out of band, using in-band messages to coordinate. The best example of this is the Jingle Xmpp extension protocol, XEP0166. This issue are being addressed by the experimental XEP0322, efficient XML interchange format. Decentralization and addressing. The Xmpp network uses a client-to-Euro-server architecture. Clients do not talk directly to one another. The model is decentralized, anyone can run a server, but not anonymous nor peer-to-peer like Skype. By design, there is no central authoritative server as there is with services such as AOL Instant Messenger or Windows Live Messenger. Some confusion often arises on this point as there is a public Xmpp server being run at jabber.org, to which a large number of users subscribe. However, anyone may run their own Xmpp server on their own domain. Every user on the network has a unique Jabber ID, often abbreviated as JID. To avoid requiring a central server to maintain a list of IDs, the JID is structured like an email address with a username and a domain name for the server where that user resides, separated by an @sign, such as username@example.com. Since a user may wish to log in from multiple locations, they may specify a resource. A resource identifies a particular client belonging to the user. This may be included in the JID by appending a / followed by the name of the resource. For example, the full JID of a user's mobile account would be username@example.com/. Mobile. Each resource may have specified a numerical value called priority. Messages simply sent to username@example.com will go to the client with highest priority, but those sent to username@example.com/. Mobile will go only to the mobile client. The highest priority is the one with largest numerical value. JIDs without a username part are also valid, and may be used for system messages and control of special features on the server. A resource remains optional for these JIDs as well. The means to route messages based on a logical endpoint identifier, the JID, instead of by an explicit IP address present opportunities to use Xmpp as an overlay network implementation on top of different underlay networks. XMPP is an extensible message-oriented middleware platform. XMPP provides a general framework for messaging across a network. Not surprisingly, this has a multitude of applications beyond traditional instant messaging and the distribution of presence data. While several service discovery protocols exist today, XMPP provides a solid base for the discovery of services residing locally or across a network, and the availability of these services. Building on its capability to support discovery across local network domains, XMPP is a perfect protocol for cloud computing where virtual machines, networks, and firewalls would otherwise present obstacles to alternative service discovery and presence-based solutions. Cloud computing and storage systems rely on various levels and forms of communication, including not only messaging between systems to relay state but also the migration or distribution of larger objects, such as storage or virtual machines. Along with authentication and in-transit data protection, XMPP can be applied at a variety of levels and may prove ideal as an extensible middleware or message-oriented middleware protocol. Widely known for its ability to exchange XML-based content, it is becoming an open platform for orchestrating the exchange of other forms of content including proprietary binary streams, full-motion video content, and the transport of file-based content. Here the majority of the applications have nothing to do with human communications but instead provides an open means to support machine-to-machine or peer-to-peer communications across a diverse set of networks. XMPP via HTTP and WebSocket transports. The original and native transport protocol for XMPP is Transmission Control Protocol, using open-ended XML streams over long-lived TCP connections. As an alternative to the TCP transport, the XMPP community has also developed an HTTP transport for web client as well as users behind restricted firewalls. In the original specification, XMPP could use HTTP in two ways, polling and binding. The polling method, now deprecated, essentially implies messages stored on a server-side database are being fetched regularly by an XMPP client by way of HTTP GET and POST requests. The binding method, implemented using bidirectional streams over synchronous HTTP, allows servers to push messages to clients as soon as they are sent. This push model of notification is more efficient than polling, where many of the polls return no new data. Because the client uses HTTP, most firewalls allow clients to fetch and post messages without any hindrances. Thus, in scenarios where the TCP port used by XMPP is blocked, a server can listen on the normal HTTP port and the traffic should pass without problems. Various websites let people sign into XMPP via a browser. Furthermore, there are open public servers that listen on standard HTTP and HTTPS ports, and hence allow connections from behind most firewalls. However, the IANA-registered port for BOSH is actually 5280, not 80. A perhaps more efficient transport for real-time messaging is WebSocket, a web technology providing for bidirectional, full-duplex communications channels over a single TCP connection. Experimental implementations of XMPP over WebSocket exist, and an Internet draft documenting this approach was published at the IETF but not yet standardized. Implementations: XMPP is implemented by a large number of clients, servers, and code libraries. These implementations are provided under a variety of software licenses. C. Comparison of XMPP server software. Comparison of IM clients with XMPP features, deployments. Several large public IM services natively use XMPP, including Google Talk and LiveJournal's LJ Talk, Nimbus, and OV. Various hosting services, such as DreamHost and GMX, enable hosting customers to choose XMPP services alongside more traditional web and email services. Specialized XMPP hosting services also exist in form of cloud so that domain owners need not directly run their own XMPP servers, including Cisco WebEx Connect, Chrome PL, FlaSoftBiz, i-pobox.net, and HostedIM. XMPP is also used in deployments of non-IM services, including smart grid systems such as demand response applications, message-oriented middleware, and is a replacement for SMS to provide text messaging on many smartphone clients. Extensions. The Xmpp Standards Foundation or XSF is active in developing open Xmpp extensions. However, extensions can also be defined by any individual, software project, or organization. For example, Google has defined a number of non-XSF extensions, which are used in Google Talk and Google+. Another example is the Federation Protocol in Apache Wave, which is based on Xmpp. Competing standards. Xmpp has often been regarded as a competitor to Simple, based on the Session Initiation Protocol, as the standard protocol for instant messaging and presence notification. The Xmpp extension for multi-user chat can be seen as a competitor to Internet Relay Chat, although it is not as widely used as IRC. Similarly, the Xmpp extensions for Publish-Subscribe provide many of the same features as the Advanced Message Queuing Protocol. Connecting to other protocols. One of the original design goals of the early Jabber open source community was enabling users to connect to multiple instant messaging systems through a single client application. This was done through entities called transports or gateways to other instant messaging protocols, but also to protocols such as SMS or email. Unlike multi-protocol clients, Xmpp provides this access at the server level by communicating via special gateway services running alongside an Xmpp server. Any user can register with one of these gateways by providing the information needed to log onto that network, and can then communicate with users of that network as though they were Xmpp users. Thus, such gateways function as client proxies. As a result, any client that fully supports Xmpp can access any network with a gateway without extra code in the client, and without the need for the client to have direct access to the Internet. However, the client proxy model may violate terms of service on the protocol used and also requires the user to send their IAM username and password to the third-party site that operates the transport. Another type of gateway is a server-to-server gateway, which enables a non-Xmpp server deployment to connect to native Xmpp servers using the built-in inter-domain federation features of Xmpp. Such server-to-server gateways are offered by several enterprise IAM software products, including IBM Lotus SameTime, Microsoft Link Server, Development, IETF. The IETF Xmpp Working Group has produced a number of RFC protocol documents, RFC 3920, RFC 3921, RFC 3922, RFC 3923, RFC 4622, RFC 4854, RFC 4979, and RFC 6122. The most important and most widely implemented of these specifications are RFC 6120, Extensible Messaging and Presence Protocol, Core, which describes client-to-server messaging using two open-ended XML streams. XML streams consist of present/, message/ and X/. A connection is authenticated with simple authentication and security layer and encrypted with transport layer security. RFC 6121, Extensible Messaging and Presence Protocol, Instant Messaging and Presence describes instant messaging, the most common application of Xmpp. RFC 6122, Extensible Messaging and Presence Protocol, Address Format describes the rules for Xmpp addresses, also called Jabber IDs or JIDs. Currently JIDs use stringprop for handling of Unicode characters outside the ASCII range, but this will be changed in the future to use the technology produced by the IETF's PRACY Working Group. XSF, the Xmpp Standards Foundation develops and publishes extensions to Xmpp through a standards process centered on Xmpp extension protocols. The following extensions are in especially wide use: data forms, service discovery, multi-user chat, publish-subscribe and personal eventing protocol, XHTML/IM, file transfer, entity capabilities, HTTP binding, jingle for voice and video. Internet of Things, Xmpp features such as federation across domains, publish-subscribe, authentication and its security even for mobile endpoints are being used to implement the Internet of Things. Several Xmpp extensions are part of the experimental implementation, efficient XML interchange format. Sensor data. Provisioning. Control. Concentrators. See also, comparison of instant messaging clients, comparison of instant messaging protocols, comparison of Xmpp server software, secure communication, simple, references. External links, Xmpp Standards Foundation, Jabber User Guide, a Euro End User Introduction to Xmpp, IETF publishes Xmpp RFCs, Xmpp Case Studies, Podcast, FLOSS 49, Xmpp Peter St. Andre interviewed by Randall Schwartz and Leo Laporte, Xmpp Wiki site IoT Systems Chatty Things.